Hi, welcome to the LEAP initiative where we teach everything around DevOps engineering and Kafka administration. Today's tutorial will be looking at introduction to Docker. Introduction to Docker. Docker and containerization. Docker and containerization. So what is Docker? What is containerization? Why does a DevOps engineer need to understand Docker and understand containerization? Why does a Kafka admin need to understand Docker and understand containerization? Now, Docker and containerization, these are fairly new tools or technology in the tech world that has reshaped everything. It has revolutionized everything regarding how we do work in the real world environment or in the tech environment in general. This is very, very, very mind blowing. It's one of the most effective technological advancement that has been made recently. So prior to having Docker, we are going to explain Docker shortly, but we want to see what it was before the advent of Docker and containerization. So from previous classes, previous tutorial, we established that developers usually run their code on their computer, and then they make changes, they render it, they see whatever the application they are building. Now, here, the computer of the developer has installed dependencies. Like maybe Python version 3.0, maybe Python version 2.1, example like that, right? We can just give an example, say Python 3.5.0, for example, right? These are all what he has in his computer to have made this to work, to make the application to run. Now, there is similarly another developer here. This was before the advent of Docker containers. He also wants to run this application. But then installed dependency on his own computer. He also has installed dependencies on his own computer and perhaps his own installed dependency. So this developer, we can say he has Python maybe 2.5.0 in his own computer. So for him, he would have to receive the application from this developer. So he needs to share maybe the script and the code base and everything to this developer right here, to this developer right here. So sends it over to this developer. Now it may not work properly on this developer's computer because they have dependency mismatch, right? They have dependency mismatch. So perhaps this application relies solely on version 3.5 and this developer is having version 2.5, so it's definitely gonna break on this developer's computer. Now it may, like a no-brainer, you would think, okay, just upgrade, this developer just needs to upgrade his his Python to 3.5 and it will be good. That's okay, but for example, this developer may have his own application running on his computer or his own application that is building, which made him to be using this 2.5, right? So that application is using 2.5, so he's not going to be because of this new application that is being sent to him, now try to upgrade his Python. If he upgrades his Python, then his own script breaks. So that's like one of those issues that we used to face then, like dependency mismatch. Some certain functionalities may not work properly, maybe depending on if this was using a MacBook and then this was using a Windows machine, right? So there are those sort of issues that we have. Always transferring a code base from one system to another has some form of dependency mismatch and issues that comes up with it. So containerization and Docker came and was invented to actually solve this problem. How does it solve this problem? It introduced a concept called containers. A concept called container. This is called a Docker container. Now, Docker container, what is it? Docker container is like a server. It's like a Linux server. So Docker container is like a Linux server because it has terminal. It has a terminal and it has file system like we saw in traditional servers when you're trying to learn Linux commands. So the same terminal where you do your ls and stuff and you do your mkdir create folder, that's what a container looks like. So what this developer now does is that he packages this entire script, right? He packages the script and its dependency. So the script is using version Python version 3.5, right? The script and the dependencies, which we are just seeing one dependency as an example. There can be other dependency. Maybe the script is using a module called Flask. It could also be part of the dependency, but for now we are looking at just Python as a dependency. Python version 3.5. So what this developer will do, let me expand this a bit. So what this developer now does is it uses Docker as a technology to now carry this script, the app, and the dependency into this container. So what does it do? Let me just make it the right top. So the developer, he now installs Python 3.5.0 and impute the app into the container. So this is what the developer now does. He will now install Python 3.5 and put the application into the container. So at the end of the day, when you look at the container will now have this. The container will have Python 3.5.0 and app.py. For example, this is the script name. So it will now have this in it. So this is now bundled up as a container. Then what does the developer do? He will now carry this container and then send it over to this developer. So instead of sending the script to the developer and then the developer is worrying about the dependency of Python that he's running, the developer does not need to worry about that anymore. The developer just need to run. Let me do this. The developer now just needs to put the container into, let me change the coloration of this and see. I'll change it to this color. Now okay, so the developer gives this guy the container. So this guy will just run the container in his or her laptop. Now this guy doesn't need to worry much about the Python dependency. It does not really matter the Python dependency he has on his own computer. All he needs to do is just run this container and then the application will be running, because the application has been given its own environment with the dependency that he needs. So let's cite more example. Let me reduce this. So I'll remove this so that I can reduce it. So something like this. So now where the beauty of this comes in is that this guy can have multiple different containers running, can have multiple different containers from other developers, right? So maybe a certain developer has maybe Python, a Python script of version 1.0.0. So it no longer becomes any problem, right? It no longer becomes an issue. You just send the Docker container, right? You send the Docker container. This one could be maybe Node.js. This one could be Node.js. It can have Java installed or anything, right? And he can have Java installed in the container, why not having Java installed in his own personal computer? And then that's no issues, because the application is boxed into its own server and its own environment, so it runs. Everything will now run perfectly. So you see, this is Python version 3.5, this is Python version 1.0, and he on his own personal computer is Python version 2.5.0. So now there is no issues, there is no dependency issue. All I need is just give me your Docker image, and then I can run the Docker container on my own computer. So this is an amazing revolution that has come into the innovation that has come into the tech world, and it's actually a lucrative skill to understand how to create Docker containers, how to create Docker image. So in this tutorial, we'll be looking at how to create a Docker image, and also how to run a basic Docker image to be able to see what it looks like. Okay, so we can look at a basic Python application and Node.js application. So we'll go into this folder, containerization, just to show a test. Now let's say we want to run a Python application first, so we'll populate the Python application in here. So now this is the Python application. This is the Python application, and we see this red line, not red, we see this yellow line. This is to indicate to us that this is a dependency, this is a module that needs to be used by the Python script, but we don't have it installed in our computer. So we don't have it installed in our computer, so it throws that line. So this is what we are talking about. Take note of this. Take note of that this is the first thing we are going to be doing. So let me put in something like a file called steps.txt. So steps.txt, we are going to say step 1. Step 1 is to install the dependencies. Now what I'm trying to do now is to run the script locally on my computer, to run it locally. So what are the steps that we followed to run it locally? So when you itemize and you know the steps that you followed to run a basic application locally, then you can now understand how to write a Docker file that will build a Docker image. So we want to write a Docker file, and I want you to understand what the Docker file is and what it is doing. So first off, we'll run the application locally. So now first step is to install the dependency. So what is the dependency for the Python application? Flask. So we need to install Flask. So we can do Python 3 install Flask, and let me see. So we can do pip3 install Flask. So it is installing. So note this, we try to install Python. We try to install Flask. So we can say Flask -- version and see. So now we can try to see if Flask has been installed. So can do pip show pip3 show Flask and see. Okay, so this shows that Flask is installed now. Python Flask version 3.1.2. So, and you see that the line that we had initially has been removed. So this like proves to us that it has been installed. So what is the next thing to do? Note that this is the port on which we are going to access this application, port 5000. So what is the next thing to do? How do you run your Python application? How do you run your Python application? You do Python, then the application name. So first off, let us go into the folder. It's in the Python folder. We are into the Python folder. Then we do Python app.py Python 3. Okay, we are seeing that so now let us run the application. We see that port 5000 seem to already be in use in my computer, so I'm changing it to port 5002, and let's see. So we can run Python 3 app.py. Oh, wrong spelling. Python 3 app.py. Okay, so we have the application running. Do not mind this red line. It's just like a warning. This is development server. Do not use production deployment. Just okay, so we can access it on our browser and see. So we can spin up our Safari and try to see. So we do localhost 5002. So this is the application. This is what it logs out. It says flags hello from Python, right? So this is just to show you how running an application looks like. This is not a fancy UI or anything. Just wanted to show this example. So now this is what it looks like. So we'll stop it. We'll do Ctrl+C to stop it. So now it has been stopped. If you check, if we want to validate that it has been stopped, when we try to refresh, this will go away, right? So it cannot connect to the server because it is down. So what do we do now? Now we want to containerize this application, because if we send this to someone, if we send this script to someone else, we will need that person to be running maybe Python 3, or we will need that person to install Flask on their local computer, and then perhaps Flask is not something they want to install on their local computer. So what we will do now is we'll package and we'll containerize this particular application. So how do we containerize this application? First thing is I will separate out the dependencies that we need. So we'll call it requirements. I'll create a file. You have to create a file called requirements.txt. So in here you put in the requirements. So in here, the two requirements that are needed is this Flask. Flask is needed, and then we can change it to any version of the Flask that we want to. And then this other dependency, which is also needed. When you have that in there, then the next thing we need to have here is our Docker file. Now, note Docker file is written like this. It has no extension. You don't put a .py or .txt or .anything. You just write it Docker file with the D being capital letter, and then this is how you write it. So Docker file. So from the Docker file, the first and most important command is from. The from command means that you want to build this Docker image. You want to build this Docker image off. You want to build it off of an existing Docker image. So you want to build it off of an existing Docker image that may already have a terminal and a file system that you can work with, right? We said like a server. So you want to take this image, you want to build it to have foundation from another image that has a terminal built in it. So we'll say from. So we say from this. This is an image and this is okay to use. If you check Docker Hub for images, you will find this Python image with this. So this Python image lets us know that in this Docker image that we are going to be creating, Python would have already been installed because our foundation is from a Python image. So that means Python is already installed. So what we do next is the next command, which is walk dir. So this command we do /app. So what is this command, right? Remember that while I was trying to run the Python app, I had to cd into the Python folder where the app.py exists. So this is like telling the container that upon startup, change into this. So we don't use the command cd. We use this command, this word, walk dir. So we are telling it to take this folder. It will create a folder called app, and then inside that folder is what it will recognize as the working folder. That is where any commands will run on. So anything you must have to put your files into this app folder for it to be able to run. So next command, we are going to copy this file requirements.txt. So this means that from here, it means upon the startup of the container, the container has recognized this app folder as the working folder. So everything is like it's now positioned inside this app folder. So we are going to tell it to copy this requirement.txt and put it into this app folder. Why do we use dot? Why do we use period? We use period because we are already inside the app folder. So what from this line 3 tells us that we have moved into this app folder. So now we are copying this requirement.txt, which will reside in the folder where your Docker file is, and then dot means we are copying it into the current folder that we are in the container. So now next command is critical. What are we going to run? Now we need to install the dependency. Remember that I had to install the Flask dependency, right? So we need to run a command. So take this out. So run pip install. So pip install is the Python install command. -- no catch drr, that's just to make it very clean, -r requirement.txt. Now it can find requirement.txt inside that directory because it has been copied into the directory from this line 5. The Docker file will build and run the command from top to bottom. So this has already run. So now it is telling Python, it is saying that upon the startup of the container, the pip, the Python that has been installed, is going to install Flask and is going to install Werkzeug. So this is crucial. Now the dependency is going to get installed together with the container. It doesn't need to get installed on your own local computer. It gets installed in the container. So all the application needs is already installed in the container, so no issues there. So we go to the next command. So now the next command will be to copy our app.py. I will copy it into the working directory, just the same way we copied requirements.txt. So now this file has now been copied into the app folder that will be inside the container. Then what will be the next thing? We want to expose the container port. So we need to expose the container port so that the application can be able to be accessed. So now what is the final thing? This exposing the application, the container port, this is unique to containerization, because the application is inside a container. So we need to expose like a door into that container so that we can access the application in that container. So now what will be the last command that we will run? So the last command will be cmd. Cmd is the command. So what is the cmd? Remember that on my own computer I did Python 3 app.py for the Python to run, but in this container we are using a Python that we can just say Python. We don't need to say Python 3. I did Python 3 because Python 3 was installed on my own local computer. But in this container, we just have the Python that can be called by the normal word Python. So this is Python app.py. So recognize the syntax, take note of the syntax. This is how you will write it when you're writing anything with this cmd. This cmd command expects this syntax. So now our Docker file has been completed. So what we can do now is to create an image out of this Docker file. Create an image out of this Docker file. So the command will be docker build -t we are going to tag it Ekele-J. We're going to tag it Ekele-J because that's my Docker Hub username, and then we call it DevOps Python, and we can say version 1.0. We can say version 1.0. Now so this tells us the Docker file. This dot tells us that the Docker file we want to use is in this folder that we are in, right? It's in this Python folder. So it is now building the image. So give it a little bit of time to build the image. Okay, so this mistake is just due to this syntax error. So requirement.txt, and then we are having s here. So just update that, and then we build again. So I'll clear, and then we'll try to just build again. So yeah, it proceeded. So now it is installing those dependencies, the flags. It is installing those two dependencies inside the container, not your local computer. Now the image has been built successfully. So how do we check? We can do docker images, and we can see all the image that I have, but I will run a command that helps me filter out docker images grep Python. So this is it. This is the image. My image has been created. 236 MB worth of space for this image. So it's quite handy to be able to know how to use Docker. Okay, so this is it, and then now we can use Docker to run this image. So we'll now create a container out of this image. So how do we do that? We'll run the docker run command. So we do docker run -p, what port? What port? We say port 222 on our port 5002 on our computer, port 5002 on our computer to port 5002 on the container. And then what is the name of our image? Our image name is Ekele James DevOps Python version 1.0. So when we hit this, Docker is gonna create a container out of that image. Container has been created. So now we can try to see on Safari, and we refresh again. So we see, now we see it running. So to also prove that it's a container running, we can check this and we can see that a container is up and running. This is what the container is up and running, showing our application. So we can kill it by doing this. So we've stopped the container. So we can run this command again to give it much more, to give the container a name. So we can do docker run -p and then --name. Container name will be James Python. James Python is the container name. Then we do -d to not populate the logs into our local computer. So it has been created. Now this gives us an ID that it has been created. Now when we check on the Docker side, we can see James Python is now running. James Python is now running. We can stop this one and delete this one. So now we can try to access it, and it is running, and then it is running. So we've successfully containerized, created an image and then containerize it. So what's the first, so what's the steps that we took? We created an image, created Docker image, to build Docker, to created Docker container. So now you can create an image and not create a container. Why? Because the image is what this guy will now send to this guy. So this guy now will send over what? He will now send over our image, which was ekeleJ / DevOps Python version 1.0. So this is what he will just send. This is what he will just send to this guy. He's not sending a file. He's not gonna send a file. He will just say, hey, hey John Jones, run this image. He will just give you a text, maybe just send it via email, saying run this Docker image on your computer to see my application. So what this guy will do is he will have Docker installed. That's the only thing he will need as a dependency on his computer. He will have Docker installed. So once Docker is installed, that's the only thing. He will then come to his computer and then run. He will do this Docker run. He will do Docker run dash. So while this developer is sending this, he can also say, hey, the app runs on port 550. That's all he needs to tell this guy. And then this guy comes here, he will do this Docker run. He can give it its own container name. He can say John test, or my name, or the dev1's app dash D, to keep it in detached mode, dash P. So he's going to expose it on his own port. If he has port 5002 preoccupied on his own system, he can decide to run it on port 9000 on his own computer, linked to port 5002 of the container, because that's where the application will be exposed. Then the image name is ekele j/devops python version 1.0. This is all he will need to run. So this is all he will need to run. So just by running this, the application will now get a container, a Docker container will get created on his computer, and then the application will be running in there. So he may not even have Python installed on his computer, so it runs in there. So that's an example of how the Docker file and Docker containerizes application so that you can send it by any means. So now what traditionally happens is, like, this guy, before sending this to this developer to use, he would have done this. He would push it into Docker Hub. So this developer will push this image into Docker Hub. So Docker Hub is something we'll take a look at shortly. Each and every one will have their own Docker Hub account. So he'll push this image into the Docker Hub for He'll push this image into the Docker Hub. Is almost like how pushing into a repository works. So he'll push it into the Docker Hub. Then when this guy runs this command is designed to automatically search Docker Hub. It's designed to automatically search Docker Hub and then pull the image and create a container out of it. So this is what it will do. It will now pull the image and create a container out of it, right? Maybe we can reposition it, like for example, say this. So it will now create a Docker container out of it. So in our classes, we are going to go in depth. We are going to see how some certain organizations have their own Docker repository instead of using Docker Hub, because Docker Hub is public. So you get to see how you connect to different repository. We are going to see how to push the image into a repository, and also how to pull it. So we are going to have such collaboration in the full-fledged class, but this gives you an idea, and with this you can actually practice with the Leap initiative playground, and you'll be able to create Docker images on the fly and just test your skills in writing Docker file and practice. So thank you for this tutorial section, and see you in the next tutorial. Thank you.